First of all, when I use the word model, what do I mean? Just a casual browse through any economics textbook or even these slides, you will notice that there's lots of graphs in economics. That's the nature of the subject. You're probably thinking, who looks at these graphs in real life? Perhaps. But the idea of the subject is we build two-dimensional models. So they're on a flat surface. It's a 2D representation of an economic scenario. I.e., it's not 3D. You don't need 3D glasses. You don't need a computer to look at that model. It's a 2D representation. There's a y-axis, there's an x-axis. I can draw it on a flat surface to help us analyze some sort of economic situation. The nature of this subject is we'll be looking at a different model for each topic, and you need to understand how that model works. And in terms of questions in the exam, rather than thinking outside the box, this subject is more think inside the box. You have to understand how the model works, and then you read the question and you answer that question with reference to the model. So you may not literally see these exact same models in your workplace in the future, but every workplace will have their own version of whatever modeling tool they have. So the generic skill of understanding a model is very useful to you, because this is the only subject you have in your undergrad degree where you analyze it in terms of models. You have to see how certain shocks will affect the model and how the model gives about a prediction. So you may not see every single model in your workplace. I acknowledge that. You will see most of it. For example, what we'll see this afternoon. But the generic skill of understanding how a model works is more what you will take from this course. So the subject is more think inside the box, think with reference to the model, and try and come up with a prediction, try and come up with a conclusion by analyzing the model that's been given to you. So the first model that we'll be looking at in this course is the PPF, or Production Possibilities Frontier for short. Production Possibilities Frontier. So it's a model about production, as the name implies. It's got nothing to do with consumption. It is simply about what are we able to do? What is our economy able to perform? So it's not about consumption, not about what we want as such. Frontier implying there's a boundary, there's a limit. Because we can't have everything, because resources are limited. Okay, we're on page 15 in your slides, which I asked you to label. So I'm sorry, I cannot manipulate the screens independently. I wish I could. So I'll just have to call out the slide page number. Otherwise I could have put a different projection on each. So we're on page 15, and we'll work through that step by step. So what does a production possibilities frontier look like? First of all, we'll assume there are just two products that this economy can produce. The reason we assume there are two products is so that we can keep the model two-dimensional. Now, I'm just going to change the example. Let's say our economy can produce books, or our economy can produce CDs. So two products, B for books and C for CDs. Yeah. Can we produce an unlimited quantity of books in a given period of time? No, because our resources are limited. So we can't produce an unlimited quantity of books. Let's say the most number of books we can produce are 5 million books. And the most number of books we can produce is 15 million CDs. Yeah? What this point represents is every single resource in the economy is involved in the production of books. Every resource is involved in the production of books. Likewise, the vertical intercept, every single resource is involved in the production of CDs. So on the x-axis, the intercept, every single resource is involved in the production of books. On the y-axis, every resource is involved in the production of CDs. So, our economy, we can produce only books, we can produce only CDs, or we can produce bits of both. We can produce only books, we can produce only CDs, or we can produce combinations of both. Now, I'll start off with a straight line, and I'll change that later. We can only produce books, we can only produce CDs, or we can produce combinations of both. For example, we could produce 12 CDs and 1 book, or 9 CDs and 2 books, and so on. Different combinations of books and CDs. Is that okay? So what a PPF, which stands for? PPF, which stands for Production Possibilities Frontier. It shows every single combination that we could possibly produce. Now, I've labeled the axes in millions, but I've only shown you 6 combinations. Now, technically, there are at least 5 million combinations. Now, because we haven't got time, I won't draw all 5 million dots, but if I did, dot, 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 if I drew 5 million dots, what would that look like? You can try for homework. I mean, you do have the whole summer break. Try draw 5 million dots, and you'll effectively get a line. In this case, I've drawn it linear. I'll change that later. So what you're seeing is 5 million combinations, which gives you a nice smooth curve or a nice smooth line. And this is what we call our PPF. It shows what we can produce with our resources. Shows all different combinations. Shows all possible combinations of 2 goods that can be produced at a given point in time. Is that okay? Now, if I call this combination A and I call this combination B, is combination A possible? Can I produce combination A? Yes. Can I produce combination B? Yes. Can I produce combination X? Yes. Because X, the only difference compared to A, X simply has less CDs, and X compared to B, X simply has less books. So if you can produce A, you can produce X. Likewise, if you can produce B, you can produce X as well. So A is possible, B is possible, X is also possible, but what's the difference with X? With X, it is possible to produce, but we have some unemployment, or we have some underemployment of resources. So we're not utilizing all our resources if we are at X. Some resources are not being used, or some resources are being used but not fully. Maybe a worker wishes to work 5 days a week, but they're working 3 days a week. Maybe someone wants an 8-hour shift and they've only got a 4-hour shift. So that's underemployment. Unemployment is there are resources which are not being used, full stop. So X is possible, but we have some unemployment or some underemployment. Now, this is terminology. We use the term productively inefficient. If we add a combination like X, we use the term productively inefficient, which we have on page 16 in your slides. If we add a combination like X, we call it productively inefficient. And likewise, if we have a combination like A or B, we can say it is productively efficient. So if we had a combination like A and B, all resources are fully employed. We use the term productively efficient. Again, that's on the bottom of page 16. All okay with that? So X is possible, A is possible, B is possible, but the difference is X is inefficient, A and B are efficient. Now, what about combination Y? Is that possible with our given resources? Y is currently impossible with our given resources and technology. It may be possible in the future, which is why I'm saying it's currently impossible. Perhaps we will discover new resources in the future. Perhaps we'll have economic growth where the population has increased. Perhaps there'll be a technological improvement which may make combination Y possible in the future. But at the moment, with our given resources and our given technology, combination Y is currently impossible. Is that okay? Say yes. Okay, back to, if you could draw a fresh graph so that you don't overcrowd what you have. Same numbers. Suppose I am currently at combination A. We are now on page 18 in the handout I've given you. Suppose we are at combination A. What are we currently producing? 15 million CDs and 0 books. At the moment we're producing 15 CDs and 0 books. Agree with that? Suppose we want to produce one more book. What would we need to give up if we wanted to produce one more book? So if I wanted to increase my production of books, I can't go here because combination Z is impossible. So I can't just increase my book production without altering my CD production. So to increase books, I will have to reduce the production of CDs. To increase the production of books by 1 unit, I will have to reduce the production of CDs by 3 units. Is that okay? What do I call what I give up? If you give up something, we use the term. If you give up something, we use the term opportunity cost. So we can say the movement from A to B, the opportunity cost of one book equals 3 CDs. To produce an extra book, we will need to give up 3 CDs. Yeah? What if I want to produce another extra book? And I'm already at B. Now combination Y is impossible, so I will again have to reduce book production by 3 to reduce CD production by 3 to increase book production by 1. So again, from B to C, the opportunity cost of one book is again 3 CDs. Now, instead of boring you for the rest of them, you will immediately notice that the way I've drawn the graph, the opportunity cost of a book is always going to be, the opportunity cost of one book is always going to be 3 CDs. Because I've drawn the graph as a straight line, so in this graph, the opportunity cost of one book is always going to be 3 CDs. So, conclusion you can write here, if the PPF is linear, linear meaning a straight line, for a linear PPF, the opportunity cost is always constant. If a PPF is linear, the opportunity cost is always the same. The graph is a straight line, so I'm always giving up 3, 3, 3, 3, 3. Is that okay? Say yes. Now, a tiny bit of maths. Do you remember slope from high school? Do you remember high school? How do you calculate slope? Slope is rise over run. Or I prefer the vertical change, triangle is change, divided by the horizontal change. Slope is rise over run, or the vertical change divided by the horizontal change. What is the slope of this graph? The vertical change is 3. The horizontal change is 1. The vertical change is always 3 in this graph. The horizontal change is always 1 in this graph. So what is the slope of this graph? The slope of this graph is 3. In this graph, the slope is 3 over 1, which is 3. What is the opportunity cost of a book in this graph? 3 CDs. The slope is 3. The opportunity cost is 3. If the slope is 3 and the opportunity cost is 3 and the slope is 3 and the opportunity cost is 3, you can conclude that if the slope is 3 and the opportunity cost is 3, then you can conclude that the slope is the same as the opportunity cost. Okay? So next conclusion, for any PPF this is true. For any PPF, linear or not, opportunity cost is equal to the slope. For any PPF, the opportunity cost is the same as the slope. Exciting, isn't it? It's the best thing you learned this summer holiday. Sorry, I shouldn't use the word holiday. It's not a holiday. It's a study session. Okay, now we're on page 21 of the handout. I've been drawing the PPF linear. Now let's change that. Let's alter it, and it is now no longer linear. I'll use a different set of numbers. Okay, my graph is obviously not to scale. I'll give you 2 minutes. Can you calculate the opportunity cost? Well, you don't need 2 minutes, but anyway. Can you calculate the opportunity cost from A to B, B to C, C to D, D to E, E to F, please? For these numbers. So if we are currently at A, producing 20 million CDs and no books at all, and we want to now produce one more book, how many CDs do we need to sacrifice? To make one extra book, we need to sacrifice one CD. Agree with that? To make the second extra book, we need to sacrifice 2 CDs. To make the next extra book, we need to sacrifice 4 CDs. And I apologize, this number should not be 6, this number should be 7. To make the next extra book, we need to sacrifice 6 CDs, and to make the next extra book, we need to sacrifice 7 CDs. Is that okay? Now, what do you notice the opportunity cost of a book as you move from left to right? What is happening to the opportunity cost as you go from left to right? Is it still constant? In the previous graph, the opportunity cost of an extra book was always 3. But in this graph, the opportunity cost of an extra book is not always 3. It goes 1, 2, 4, 6, 7. As you go from left to right, the opportunity cost is always going. The opportunity cost is always going up. So when you have a curved PPF, conclusion, if the PPF is concave, which is curved, if the PPF is concave, the opportunity cost is always increasing as you go from left to right. If the PPF is concave, the opportunity cost is always increasing as you go from left to right. So what is happening to the slope as you go from left to right? Is the graph getting steeper or flatter? As you go from left to right, the graph is getting steeper. As you go from left to right, the slope is going up. Is that okay? Now, I haven't told you why it is curved. but I just would like to establish what the opportunity cost would look like if it is curved. Our previous PPF was linear. It was a straight line. The opportunity cost was always equal to, when the PPF is linear, the opportunity cost is always equal to the same number, in this case 3. Now, I haven't told you why I've drawn a curve, but if it was curved, the opportunity cost would not be the same. In fact, as you go from left to right, the opportunity cost will always be increasing. The slope will always be increasing. Now, I'll give you a 7-minute break and let you ponder why it is curved. Maybe you can discuss with your new friends why they think it is curved. The opportunity cost of moving from A to B was 1 CD. The opportunity cost moving from B to C was 2. C to D was 4. D to E was 6. And E to F was 7. As we moved from left to right, the opportunity cost always went up. We're on page 21. Even in the graph you have on page 21, the opportunity cost is always going up. Now, what we're going to do is construct the graph on page 22. The graph on page 22 is called marginal cost. What is marginal cost? It's the extra cost of producing one extra unit. So we've got books on the x-axis. One, two, three, four, 5. According to our model, what is the extra cost of producing the first book? According to our model, what is the extra cost of producing the first book, which is from A to B? 1 CD, yeah? The extra cost of the first book is 1 CD. That's the extra cost of the first book we have to make. What is the extra cost of the second book, B to C? 2 CDs, 19 minus 17. The extra cost of the second book is 2 CDs. What is the extra cost of the third book? C to D. 17 minus 3, which is 4. The extra cost of the third book is we have to sacrifice 4 CDs. What is the extra cost of the fourth book, D to E? We have to sacrifice 6 CDs. And E to F, we have to sacrifice 7. CDs. Now, if we connect these, This is a graph of marginal cost. The feature of this graph is that it is always going up, because the opportunity cost of an extra book is always increasing. The opportunity cost of an extra book is always increasing. It is always going up. How did I measure the opportunity cost? I measured the opportunity cost. Marginal cost is measured in terms of CDs I have to give up. I'm measuring marginal cost in terms of CDs we have to give up. Underline have to. The marginal cost of an extra book is always going upwards. Is that okay? The extra cost is always increasing. So these numbers, the 1, 2, 4, 6, 7, are actually straight from this PPF. 1, 2, 4, 6, 7. Because the PPF is concave, the marginal cost is always going upwards. Is that okay? Now, I didn't tell you why the PPF was concave to begin with. Why is the PPF concave in the first place? Now, what resources would we need to make books? Paper, an author, some printing press, and whatever other resources we need. Ink to make books, yeah? What resources do we need to make CDs? I have no idea. We need an artist to sing the songs. And what are the CDs actually made of? Silica? Plastic? I have no idea. We'll need different resources to make CDs. We'll need different resources to make books. The resources that are used to make books are not necessarily the same as the resources that are used to make CDs. So if all the resources we had in the economy could be represented by this box, let's say this box represents all the resources our economy has, and we only have 3 resources. We have plastic, we have paper, and we have, oh, that's nice, 3 P's. I didn't even plan that. Plastic, paper, and people. Economics is so exciting, people would like to just come and listen from the general public. Does this happen in your other subjects? Would anybody walk into a marketing or accounting lecture just like that? No, only in economics, yes. Even if it's December. Again, the reason I'm mentioning these 3 resources is the plastic is really useful for making CDs. Paper is really useful for making books. People can write books or they can sing songs. They can be used to make both. Okay, so if we're up here and we're making only CDs, that means all our resources are making CDs. That's the plastic, that's the paper, that's the people. Every single resource we own is currently involved in the production of CDs. If we want to start making some books, what resource is currently wasting its time producing CDs? the paper. So if we want to make some books, we would move some of this paper out of CD production into book production. Would we lose that many CDs if we move the paper away from CD production into book production? No, because this paper wasn't useful in making CDs in the first place. So if we are at A and we want to start making books, increase book production, we would move paper from CDs into books. You wouldn't lose that many CDs, but you would gain quite a lot of books. So you'd lose a few CDs, maybe the paper to make the album covers, but you would gain a lot of books. Because the paper is not really useful for making CDs in the first place. So at point A, all our resources, the plastic, the paper, the people, are all making CDs. We want to start increasing, we want to start making some books. So we move some of this paper away from CDs. We lose a few CDs, but we gain a lot of books. The reverse, we are at F. Every single resource is producing books. If we want to make some CDs, which resource would we move away from books? The plastic. Would we lose that many books if we did that? If we move the plastic away from book production, would we lose that many books? No. Because the plastic wasn't useful in making books in the first place. Would we gain a lot of CDs? Yes. So what's happening here, if we are at F and we want to increase CD production, we move the plastic from books into CDs. We'll lose a few books, but we'll gain a lot of CDs. Yeah? Now, just stop writing for a second. So as you move your way move from left to right, look what happens to the PPF. It starts out flat and it ends up, that's very ugly. It starts out flat and it ends up steeper. So as you go from left to right, you get a curve or a concave shape for your PPF. Yeah? So why is the PPF concave? Because resources are... Sorry, I think you said it. No. Sorry. Resources are changeable, but they are not perfectly changeable. Some of them are really good for making CDs. Some of them are really good at making books. So the reason it is concave is because resources are not perfectly changeable or perfectly adaptable to both goods or all products. If you could add that, please. Why is the PPF concave? The PPF is concave because resources are not perfectly adaptable to the production of all products. Essentially because resources are different. That's why the PPF is concave, because resources are different. They're not perfectly adaptable to the production of all goods. Some are really good at making books, some are really good at making CDs. So if they're really good at making CDs, the amount of CDs you gain is a lot compared to the books you have to sacrifice. If they're really good at making books, the amount of books you gain is a lot compared to the CDs you sacrifice. So because resources are different, you get a concave PPF. Does that make sense intuitively? Yeah, some are really good at making books, some are really good at making CDs, some are good at making both. Like the people can be trained to make both. So we started with a linear PPF today, but the more realistic case is a concave PPF. And if the PPF is concave,